Hiya, so in this video we're going to look at the fetch, decode, execute cycle. So this is going to follow on from the video on the CPU and the von Neumann architecture. So let's get started. What we're going to first of all look at is just a quick recap of the von Neumann architecture. So as you can see here, we've got a few different parts. So we've got the control unit over here, which controls sort of the whole CPU, controls the flow of data, and it keeps track of where the memory address is going to or coming from, and where the instructions are. You've also got the program counter, so this holds the instruction for each cycle. You've got the arithmetic and logic unit, so this performs all the arithmetic calculations, so addition, subtraction, multiplication, division. It also does things like binary shifts. It does anything to do with binary logic. So if you've done logic gates before, come across maybe AND or NOT gates, it will perform all these as well. And it's also got the accumulator in here as well, inside the arithmetic logic unit. Next we've got the registers, which are quick sort of types of memory that things get stored in, and you've also got inside these registers two examples, which is the memory address register that stores the address of the instruction or the data, and then you've also got the memory data register, which is what actually holds the data or instruction. Okay, so that's just a quick recap of the von Neumann architecture. What we're going to look at now is something called the fetch, decode, execute cycle. And this is basically a way of visualizing how the CPU carries out the processes of these instructions and the data, because obviously it does this billions of times a second. It does it very, very fast, so it must have some sort of process that it has to follow. So what we're going to look at is the first stage, which is the fetch stage. Okay, what the fetch stage does is it copies the memory address from the program counter to the memory address register. Okay, so it copies the location from the PC to the MAR. Then it will copy the instruction stored in the MAR address to the MDR. Okay, so it will copy whatever data it has got from the location into the data register. Okay, or it may increment or increase the program counter to the point of the address for the next instruction, ready for the next cycle. Okay, so the fetch one essentially goes out and gets the data and brings it back, or it goes out and gets the address and brings it back, or it will get the program counter ready for the next cycle. Okay, so all the fetch one does is it moves data about and copies it. It doesn't actually do anything with this data. Okay, the next stage we've got is the decode. Now the decode stage is where the instruction in the MDR is decoded by the CU, or the control unit. Okay, the control unit will then, once it has decoded this instruction or data, it will then prepare for the next step, so it might load the values into the MAR or the MDR depending on where they need to go. Okay, and it also may put other values in registers if they're needed. Okay, and then the final stage we've got is the execute, and this one's fairly straightforward. Whatever has been decoded will be carried out, will be performed. Okay, so whatever you have had sort of decoded over here, the instruction will then be performed. So for example, it could be loading data from the memory, it could be writing data to memory, it could be performing a calculation such as a logic operation or addition, subtraction, anything we talked about before that the ALU can do. Or it may be changing the address in the program counter, or simply stopping and halting the program altogether. Okay, so this cycle follows through and it goes on to each stage, and all it does is it keeps going round and round and round until eventually there's no more instructions or data and the CPU is not needed, or the program is stopped, or the computer switched off. Okay, it will just continuously cycle through this fetch, decode, execute cycle. Okay, so what I have done is I have found an exam question that OCR have asked previously. So it says identify 4 events that take place during the fetch execute cycle, and as you can see, this is a 4-mark question. Okay, so when you are answering this question, what you want to try and do is make sure you've got 4 different points in this answer, because it says identify 4 events. So you're going to want to try and find 4 different points. Now if we just go back here, you can clearly see there's 3 obvious ones. because the first stage is fetch, the second stage is decode, and the final stage is execute. Okay, what the exam question is looking for is for you to identify those three sort of stages and then be able to go into a little bit more detail. Okay, so here are some possible answers. Any of these bullet points were on the mark scheme. As long as you have got any 4 of these combinations, you can get 4 marks. So the first one is to say the instruction is fetched from memory. The second one says the instruction is then decoded, and the final one says the decoded instruction is then executed, so the CPU performs continuously. Okay, that is literally the F, D, and E of the fetch, decode, execute cycle. So they are the 3 main stages. The next one we've got is then the process is repeated. So as we could see, the FDE cycles round, it loops continuously. So that is saying it cycles round, it keeps going until it needs to stop. Okay, and then you could also get some marks possibly for saying the PC is incremented, the instruction is transferred to the MDR, or the address of the instruction to be fetched is placed in the MAR. That is all it is doing, is going into a little bit of detail of what I described through the different stages in the cycle. Okay, so I hope this has helped you understand the fetch, decode, execute cycle a little bit better.